Okay, welcome everyone. Good morning, and welcome to the Institute of Mathematical Sciences, which is also known as IMSc. And actually, welcome to our young minds who have come from various institutions like colleges, etc., at these early hours over here to take part in this program we are having. So IMSc is a national institution and where we do fundamental research in theoretical physics, theoretical computer science, mathematics, and biology. We have advanced programs like PhD programs, MS PhD programs, and also many summer research programs for college students, etc., etc. We also host a lot of exciting scientific conferences, workshops, etc. over the years, national and international level. There is something which we take quite a pride in, is essentially organizing many outreach activities. Okay, and these are usually done in collaboration with, sometimes with many different colleges, schools, Tamil Nadu Science Foundation, Tamil Nadu Academy of Sciences. So it gives me a lot of pleasure essentially to tell a few names of such programs. One is Facets, which is basically a mathematics program for college students. Then there is Kanita Kanakam, which is also a mathematics program for school students particularly. And I think some of you probably have come here or have heard of this. Then we have Vigyan Pratibha for teachers, workshop for regional government colleges across Tamil Nadu. We have specifically some very new programs based on origamis and toys where we teach, like how to make them, and also we explain the principles behind them, physics and maths behind this kind of constructions. Then we have something called a flagship program, Science at the Sabha. So this is essentially some very general public talks given by some expertise all across India, but usually it is held in Chennai, and we usually organize it as part of IMSc, and usually it takes place in Chennai Academy of Music. Anyway, so we have also a long-time association with, as I said, with Tamil Nadu Science Foundation, and while doing that, we also publish a lot of science books, sometimes written in Tamil as well as in English. And so similarly, today also we have gathered, right, to take part in one of these outreach programs, which is part of this ongoing conference that we are having, memorizing Professor Amol Kumar Raichaudhuri. So to say a few words about Amol Kumar Raichaudhuri, who was also known to us as AKR. So he was an Indian physicist known for his pioneering work in general relativity and cosmology. And of course, he had many significant contributions, which one of them is the Raichaudhuri equations, etc., etc. I don't want to get into too much details. You will hear a lot of these things. More on the ground level, I would like to mention that he was also a very beloved teacher for many of us. Not for me, but because I have not seen him, but for many of the other senior members who are present here. He wrote many excellent books. So to name a few, one in classical mechanics, and probably you have read it or something, or maybe you can see it in the library. And there was another one in electromagnetism. There was one in gravitation and cosmology. Okay, so there are these beautiful books which actually, when I was in my college, I read them a couple of times. Okay, so at IMSc, what is happening in the last 2 days, we are celebrating his centennial year. And this is actually a conference where we have joined, together to discuss his work, okay? So not only the scientific part, also how he was as a scientist, as a teacher, and also as a visionary, okay? And because of whom, it has the gravitation or cosmology, the field of gravitation and cosmology has taken some shape in our country. Okay, so the way it is planned today, so because you guys are here as a part of outreach, we plan to have an exciting talks more on the non-technical level, okay, covering exciting phenomena such as black holes, star collapse, and hidden dimensions. And we will see more about this. So without further ado, So I would like to invite our director, Professor Ravindran, to say a few words, and we'll go ahead.
Good morning. Welcome to all of you to this wonderful program, which has been going on for the last 2 days. Today is the closing date. As he said, elaborately about the purpose of this meeting. Also, why we want to have this, this third day with all of you. I mean, the program will be incomplete without having a program of this kind, because that is what AKR did in his entire life of, educating young minds. I think it would be a good idea to have a feel of what he did, and also the kind of physics that all of us are doing, inspired by his teaching. I mean, as he said, there are many of faculty members here who were students of AKR, and he spent all his time educating, young minds who are interested and inspiring, actually. So I hope this program will be, successful with the final day of discussing about his works and also other interesting works that can inspire, I hope, all of you to actually do research in fundamental science, which is very important, as you all know. Without fundamental science, you cannot have technology, you cannot have anything that you can think of these days, actually. So it's very important that we pay attention to fundamental science, and that's all these people actually try to actually communicate to us during their time. So I believe that this will be the right tribute to the great man, AKR, having you all here and also passing what we learned actually so far in physics. So thank you for coming, and make use of this entire day, paying attention to all the talks, and have fun. Thank you.
In this outreach program, the first talk will be delivered by Professor Palash Baran Pal. He's an eminent scientist and a very good speaker. So I would request Professor Palash Baran Pal to take the dais. The title of his talk is AKR and the Teaching of Physics.
Good morning, everybody. First of all, I want to thank the organizers for inviting me to this conference. Of course, all speakers say that at the beginning, but I have a special thanks to give them, because probably I'm the only speaker in this conference who doesn't know what Raychaudhuri equation is. So my association with Raychaudhuri, or AKR as we call him, is not through his equation or through his work in gravitation and cosmology. My association with him was as a student. I was very fortunate to have him as our teacher, both during my BSc and my MSc courses. In my BSc time, he taught us thermodynamics in the second year. And during our MSc, he taught us a course on classical mechanics. I will talk about both these courses a little bit to give you a flavor of what kind of a teacher he was. In the thermodynamics course, you have to understand that we were in the second year of college, so barely out of high school at that time. So I should say that he was brilliant, but we were not really at that time grown up enough to appreciate the brilliance. we had to grow up a little more so that we could appreciate where his uniqueness lies. It has also to be said that in a BSc course, you are sort of tied to a syllabus very much, and probably AKR also felt the pressure of being tied, and he had to present thermodynamics in the way that it was supposed to be done because of the syllabus, which now I do not think is the best way of teaching thermodynamics to physics students. I mean, this approach of thermodynamics was somewhat historical, how this branch of physics grew up through experimental input, and how people tried to find equations of state for different systems, and from that tried to deduce relations between heat energy and all other kinds of energies. The problem with this approach is that an equation of state does not really describe all thermodynamic properties of a system. It's like saying this. Suppose I tell you that there is a function y of x, and I don't tell you the function, but I give you the tangents at all possible points. But with this information, if this is an answer that fits all the tangents, then this will also be an answer which fits all the tangents. I mean, in other words, when you perform integration, indefinite integration, there is a constant, right? And you cannot determine the constant from this information about the tangents. So equation of state is like this. For example, knowing the equation of state of an ideal gas, you cannot find what is the chemical potential of the ideal gas. Okay? So there are these kind of limitations. But as I said, these limitations were put forward by the syllabus of the university, and AKR had to abide by those rules. There are some brilliant things which came out in that course also, but I will come to them later. Let me now talk about the classical mechanics course, which, as I said, was in our MSc class, and this was the first year of MSc. In fact, probably the first class of our MSc course was AKR's class. And I mean, it was like hitting a 6 in the first ball. In the first lecture, he completely bowled us over. Why? I will give you some example. People who haven't seen AKR or haven't seen AKR's teaching will have to guess the whole scenario from what I read from his writings. And people who have seen AKR, they will imagine the AKR visuals with it, which I cannot reproduce very well. So in the first lecture, he said that you have come after your BSc, you know Newtonian mechanics. The object of this course is to talk about formulations of classical mechanics which came out after Newton. So let me add a footnote. So for example, there would be Lagrangian formulation, Hamiltonian formulations, and so on. Okay? But then AKR says, so why do we need a formulation after Newton? What was wrong, or what was incomplete, or what was unsatisfactory in Newton's formulation? And then I have to find my glasses. At this age, in order to read something, you just the book is not enough. You also need the glasses. Okay. So I will read a little bit from this book, Classical Mechanics, which Arnav has already mentioned. And this is, as far as I know, it was AKR's first pedagogical book. He wrote a book before, Theoretical Cosmology, but this is the first book for pedagogy. So AKR starts like this. Let us state the first law. It says, every body, I'm emphasizing where there is a bold-faced letter in the book, every body continues in its state of rest or of uniform motion in a straight line unless it is compelled by external forces to change that state. So there are 5 places where boldface has been used: every body, state of rest, uniform motion, straight line, external forces. Then he says, our first question is, what do you mean by every body? At first sight, just anything in the universe. But let me give you an example. Suppose I put here a time bomb. It is at rest, and we conclude from Newton's first law that it will remain at rest, so we have no problem with it. Nothing to fear about. But at such and such hours and such minute, it explodes. And the splinters run in all directions. Obviously, the body that is a bomb, or whatever exists of it, can no longer be said to be at rest, as it was some time ago. And no external force was applied at any stage. So is this an exception, indicating a breakdown of Newton's first law? Rather, we see that we must define what exactly we mean by the term every body, so as to exclude cases as the above. And he goes on like this with all of these boldface words or phrases, and I will not read everything, but maybe some of them. Next comes the phrase state of rest. A state of rest is essentially subjective or relative, if you like. For example, the quiet boy who is at rest in my class is not at rest relative to an observer at, say, the sun. For all the while, he is moving in an ellipse along with the earth itself, to say nothing of other complicated motions of the earth. So the question arises, what should be the frame of reference for the use of the phrase state of rest? Would any reference frame be equally good for our purpose? And then he says, obviously not. Because if I think that somebody is in a state of rest, and another person is accelerating with respect to me, with respect to that person, this other guy is not in a state of rest. So we'll have to define which are the observers who agree on the state of rest of a system. And this kind of observers, or this kind of observing frames, are called inertial frames. So in that sense, Newton's first law is just a definition of inertial frames. There are some frames in which it holds, there are some frames in which it doesn't. That's not very respectable for a law, a very fundamental law of physics. The question that arises now is, do such frames really exist? Or in other words, is the first law true in any frame whatsoever? Operationally, it does seem possible to attain a condition where his body is subject to no force whatsoever. One has to be content to a degree of approximation. And he goes on like this. Then the next topic is the straight line. How can one be sure that a line is straight? And please don't tell us that you take a ruler and place it across it, because how did the makers of that ruler be sure that the side of the ruler is straight? Okay? You can say that it is just the line of shortest length between 2 points. The question is, how do you operationally verify it? Will you take all possible lines and then decide which one is the shortest? Again, you may say that the straight line is the path taken by a free particle. But then a part of the first law reduces to the definition of a straight line. Or you could declare that a straight line is the path that light takes, but that only shows that Newton's law as it stands is incomplete and has to be supplemented by the law of light propagation. Lastly, we come to force. And this I have to read about 3 or 4 paragraphs, because this is excellent. This is what bowled us over. I mean, the previous ones were just sort of some swings which went past our bat, but didn't really connect to the bat, and it went to the wicket keeper. But this is the one which completely skittled our stumps. Lastly, we come to force. Initially, the concept of force was a very intuitive one. It was a push or a pull. Now let us consider a piece of chalk. If placed on the table, it remains at rest. Now suppose I lift the chalk to some height and just release it. Okay, this is the last part I am not demonstrating. Just release it. It will begin to fall. And if you care to measure, the motion is accelerated. How is it possible? For apparently, there is neither any push or any pull on the chalk. You will say that, oh, come on, there is the force of gravity acting on the piece of chalk. Well, I ask, what is the proof of existence of such a force? You argue that the acceleration of the piece of chalk coupled with Newton's first law shows the existence of such a force. Then the whole argument goes on in a circle. Should we not rather say that we have taken Newton's laws as sacred and just to save them have affirmed the existence of a gravitational force? In a very similar way, we were led to discover electromagnetic forces to save Newton's laws in other circumstances. Now let us suppose that a sadhu has acquired such a power that he can sit quietly in air without any support. This is a phenomenon called levitation. Suppose too that the sadhu is no fraud and he can really do the trick. Then what is the situation? A body is in a state of rest, although a force, that is the force of gravity, acts on it. We could say that there are supernatural phenomena where Newton's law do not apply. But I think we would prefer a different approach. We would bring in a new force called, for example, the yogic force into our physics. We would say that the sadhu has been able to balance gravity with the help of this yogic force. That saves Newton's law again. We would then proceed to find the sources of this new force, determine the laws, assuming hopefully that such laws do indeed exist, and finally proceed to find out the field equations. Perhaps the enterprising theoretical physicist would attempt a quantization of the field. If it brings derisive smiles on your lips, I can only tell you that I am recapitulating the history of physics in a hypothetical context. As he said before, this is exactly what happened to history of physics. Wherever you see that something is accelerating without you being able to see any force, you just invent a force. And that's how you save the thing. So he concludes that so Newton's first law gives us nothing. And it was a shock to all of us. Here we are, great Newtonians. And in the first lecture, we hear that Newton's first law gives us nothing. But that was not the end of the shock. Then he comes to second law. What is second law? Rate of change of momentum is equal to the force. Well, Newton's didn't say equal to, but we can always take the units such that it's equal to. Momentum was not introduced before. Force was not introduced before. You do not introduce two new things in one equation. That's against the rule of any rational discussion. So he says that so second law has two unknown things and is claiming that they are equal. Second law gives us nothing. Oh my God, where do we go from here? Fortunately, he says the third law actually helps restore some of the things, but I'm not going into that. The point is, we were spellbound, to say the least. Normally in the class, one comes with a notebook and a pen and takes notes. We did not know what to note. Okay, so we were just sitting there. And at the end of the class, there was a decision which was taken between me and my friend Sumit Das. So either I told Sumit or Sumit told me, we'll have to write this up. This is a gem. Okay, so we went back home, and both of us tried to write down whatever we could remember. Of course, he said that we could have communicated while writing, and just one person could have written it down. The problem is there was no Google Meet at that time. You can probably guess that. But what is worse is that I did not have a telephone even at my home. Okay, so we could not communicate. So we wrote down independently. And then Sumit said that, okay, we'll do one thing. We will, Sumit has a typewriter even at his home. His father has a typewriter, maybe it's best to say. So he said, okay, I will type it up, just taking the best part from your notes and my notes, and we will show it to AKR. So Sumit actually typed it up in the evening. But then we had a second thought. He said, no, let's not make him conscious that we are actually taking this down. We will tell him after the end of the entire course. And let us continue this thing for the rest of the course. Except for the rest of the course, we will not be so much spellbound. We knew that we are going to see extraordinary things. So we would both take notes, and after one class, I will take Sumit's note and go home. And next class, Shumit would take my notes and go home, and we will prepare the write-up from there. Now the next problem. Shumit had a typewriter. I did not have a typewriter. But the first one being typewritten, we would be crestfallen if the rest would be handwritten. Okay? So we have to type it. So this was one good thing that happened to me, that I went to a typing school. Fortunately, it was owned by somebody in our locality who knew me. And in earlier days, he was very worried about my future. Like when I was in class 8, I still didn't know how to ride a bicycle, which was unheard of in our locality, let us say. I mean, so he once called me up and said, I think you should at least learn to ride a bicycle. At least a newspaper boy's job or a postman's job will be open to you. Think about your future. And so I learned bicycle riding. So now I again went to him and said, I have to learn typing. He said, oh, I'm very glad, because you are closing your doors for having a secretary's job. I mean, I should say honestly that at that time I was a little bit offended. By this time, our higher secondary results were out, the BSc results were out, and I could probably say with some confidence that I will not have to take a newspaper deliverer's job or a secretary's job, okay? But he was not so confident. So he said, okay, so you should start with a quick brown fox. I said, I don't have time for quick brown fox, okay? I have to do classical mechanics notes. And I have them handwritten, I'm just going to type them, okay? So he said, come on, this is the way everybody learns. I said, this is not the way I will learn. If you can agree with it, then I'm going to do it. He said, fine, but one thing, I'll not take any money from you, because then you will tell that he has taken money and he didn't give me the proper education in typing. I said, oh, it's even better for me. Fine. So I learned typing. And I learned typing so well that I could actually type faster than most secretaries at that time. And when computers came, I was a natural in typing. Actually, people gave me things to type. So I was doing a secretary's job, but without any monetary remuneration. So Shumit and I prepared all these notes and then took them to AKR at the end of the course as we planned. And now it is his turn to be spellbound. So what have you done? I have never imagined something like this will happen. I said, okay, it's yours now. And we really wish that it should be turned into a book. I said, okay, let me first look at it and we'll decide. Now, he took quite a while to decide. But then you see that it actually came out as a book. And this is the first printed citation that both Shumit and I got, because in the preface of the book, he thanks us, Shumit and Palash. And the book came out. But actually, it's a pity that we didn't see the book when it came out. By this time, both Shumit and I had left India, and we were both in the USA. And we did not even know that the book has come out until much later. At that time, there was no emails and so on, so nobody even bothered telling us. And nobody would take up the task of writing a letter just for saying that the book has been published. That would be too much. So we came to know about it much later. Actually, I wish that we had known when it came out. Now, the book contains his way of approaching Newtonian, I mean not post-Newtonian, I mean after Newton classical mechanics. But it doesn't contain his lecturing style. It cannot. So I have to give you some idea, and it has to be imperfect, but still I'll have to try to give you an idea of his lecturing style. Point number one, he would come to the class just like this, with no other props, no notes in his hand or nothing else. He would just come by himself. He would wear a dhuti, and the end of the dhuti would be in his left hand, and he would just walk in. That's the scenario. And then he would start writing on the blackboard and give lecture at the same time. Now, this was something that also amazed us. And this happened not in the classical mechanics course. This happened already in the thermodynamics course in the BSc level, at the BSc level, when he taught us. The point that we felt, and he never said it explicitly, he would never say that. The point is that physics should not appear as a series of rehearsed things or things that comes out with a prop. When physics is taught, the best way to make it feel is that it comes spontaneously out of you. It is something internalized in you, and it comes spontaneously. In this sense, it's like music. Of course, you have to prepare yourself. You have to go through rigorous periods of preparation, like in music. But when a great musician sings or plays, you would not feel that. You would feel that he is creating something at that moment. He is feeling those words in the song, or he is feeling those tunes in the music at that moment. This is what you will have to feel. And it's the same thing as in physics. I mean, I'm not saying that this has to be specific for physics. Maybe it's true for many other things. But it's also true that it's not true about all things. There are things which are sort of human-made laws, like the things that people learn in maybe commerce or maybe management, those things. I don't know this subject, so please forgive me if I'm making a comment outside my field of knowledge. But physics is laws of nature, and it should come out naturally. This is the feeling that you should get from a good teacher of physics. And that is exactly what we got from AKR. And at that stage, we did not get it from many other professors, I should say, with all respect to all of them. But there were not many who gave us that feeling. And personally, I am very much indebted to him for giving me this feeling, because I have always, since the first day I started giving lectures, I have tried to copy AKR. Okay, I was a student in the class and I was a student of him even when I was teaching in the class. He was my role model in this. I was trying to copy the way AKR taught us. I was trying to show the students that it is something internal that is coming out. I have not memorized something and just putting it down on the blackboard. Sometimes I make mistakes on the blackboard. AKR also did, okay? And he would correct it, or we would correct it, and that's how it goes. It's an interactive exercise, and it should go on like this. The other thing about his style of teaching, I should say, and in this case I should say he was the only person whom we found in our college time and even university time who would mix a lot of humor in his lectures. When we first prepared the lecture notes of his classical mechanics, Shumit and I, we had all these funny comments in those notes. When the book came out, I felt really sorry that he actually cut out those comments. He said, no, those are silly comments. But those silly comments were very good. And, sometimes humor is good even for appreciating the subject. It's like that line of the famous song from a musical. Just a spoonful of sugar makes the medicine go down in a most delightful way. So a spoonful of sugar is the humor, and it helps the medicine go down. Unfortunately, I do not remember many of his humorous comments. I can remember one or two, and those will serve as examples. Once in this course of classical mechanics, he was saying something about the conservative force. And then he just pointed out, then he just said, you must know what conservative forces are, don't you? And of course, there were some nods and some blank faces in the class. So then he picked up one person in the class and he said, you, can you tell us what conservative is? You understand that I do not mean the kind of people who had very old and hackneyed ideas about society or politics. It's the conservatism that I'm talking about in physics. Do you know what it is? So that was one. For the other one, I have to use the blackboard again. Let me just write a few lines before I tell you what his comment is. Suppose I have three variables, x, y, z, which are interrelated. Now, interrelated means I can write z as some function of x and y, or I can write x as a function of y and z, or the third one. Okay? Let's take this. So this means, by chain rule of differentiation, that if I take a little variation of z, that would be del z, del x at constant y times dx plus del z, del y at constant x dy. Okay, this is just the chain rule of differentiation. Now suppose that I am moving while taking this thing, I'm moving on a path where z doesn't change, where z is constant. That means this part is 0. right? So this part is 0. And then this part I will write as dx with a subscript z to remind me that I have kept z constant. And this part I will write as dy with a subscript z. Now let's divide by dx, by dz, sorry. So then that would give me del z, no, sorry, by dx. So I'm now dividing by this thing. Okay? So plus del z del y x, and now this is at constant z, right? I divide this dy by this dx at constant z, and this should be 0. So that means that if I start from here, so I take it on the right hand side and then bring back things on this side. So there is a del z del x at y. Okay, let me take it just on the right hand side and write it like this. Del z del y at x, del y del x at z. This is the equation. We all need it for doing a lot of thermodynamic identities. So AKR derived it on the blackboard. And then he says, you might think that I have del z del x here, so I can just cross out the del y, and then I get del z and del x. But unfortunately, that doesn't work. There is the treacherous negative sign. So look at the use of the word treacherous. There is this treacherous negative sign. I still remember after, what, more than 45 years, I still remember that comment. So this was like him, humor. The other thing that we didn't really appreciate at that time, but I appreciated much later, that he used to really know, when it came to the names of the scientists, he used to really know the names, how it should be pronounced. I mean, if we didn't get a thermodynamics course from him, probably we would have said Clausius, like many people say, but he would say Clausius. Okay? He would say Carnot. And we didn't take any quantum mechanics course from him. If we did, probably we would have learned to pronounce Schrödinger's name, which many people say like Schrödinger. Okay? So he was very, very careful about these small things. Now, this was AKR in the class. How was AKR outside the classroom? Outside the classroom, he was always very helpful for the students with many different kinds of problem. We have gone to him for a solution, and he came out and tried to get a solution. I'll give you an example or two to understand what kind of things we mean. We joined Presidency College as students in 1972. Now, 1972, around that time, was a sort of transition time, I would say, for West Bengal. The years before that were the years of Naxalite revolution, and by 1972, it almost was suppressed, and a new election happened in 1972, and a new government came in, and they this government or their student wing tried to take up all the student bodies in all colleges and universities by hook or by crook. Now, and there was a lot of conflict because of that. Now, in Presidency College, in our department, there was a student who was sort of a very big leader of this Naxalite kind of politics. Of course, the movement has subsided by that time, but he still believed in what he believed. Okay? And this government's student wing did not like that. That's also understandable. What is not understandable is that this new student wing thought that if they beat the hell out of this guy, then he will start believing in their doctrine. So very often they would look for this guy and try to beat him. Literally. Okay? Now, one day they came into our department. These people were mostly outside the physics department, I should say. I cannot remember anybody in the physics department who were in that party. So one day they came to the department and the classes were going on and they were waiting outside just because this guy will come out and then they will start beating him. Okay? And this guy actually sensed that there is something brewing outside. So when the class ended, he did not come out. In Presidency College, there was this system that the classrooms, one side is the corridor where you go out, and the other side is the teachers' rooms. So he went out through the other side and hid in one of the teachers' rooms. We don't know which one. I still don't know. But that's unimportant. He was there. And then these new guys, the people who are new in power, they were trying to find him out. And then we said that we have to do something. This cannot be tolerated. So we all stood in the corridor and said, you cannot enter the classroom or anything beyond that. So we created a blockade. Okay? And it was going on between them and us. And during this time, somebody had this bright idea, I don't know who. He went downstairs and tried to find a professor because he thought that if a professor comes and say, then it will carry more weight. Certainly it would. And he found AKR. So AKR came. And then it was this. This one group who were trying to beat the guy, AKR, then us. And behind us, the guy who is to be beaten. Okay? So AKR came and said, what happened? Why are you here? I don't think you would belong to this department. So why are you here? I should say that all these words are translated, and always in translation something is missed, but that cannot be helped here. Okay? So those guys said, sir, we have come to find ABCD, the name of the person. I said, oh, you came to find him. But I got the news that he is in the teacher's room. So you will not find him. And he said, why shouldn't we find him? You can just ask him to come out. He said, why should I ask him to come out? Somehow, he doesn't want to face you. And he is in our rooms. So why should we bring him out in front of you? And he said, sir, we want to have a talk with him. I said, okay. But I have the feeling that you don't like him very much. And I have also the feeling that he doesn't like you. So it's best not to talk. So then, now, I should say that it is probably impossible for you to imagine, if you hadn't lived in Calcutta or West Bengal at that time, how much courage it took to say these words to these people. Okay? It was unthinkable. Now, then he said, no, sir, it will be just a very short talk. We'll just tell him, we'll just explain to him some things. He said, yeah, I understand what you're saying, but he doesn't want to be explained. He has his views and you have yours. So it's best to keep it that way. And then this guy said that, sir, you are not understanding the thing. Suppose a child makes a mistake. Now the father will have to correct him. AKR said, oh, I didn't understand that you are his father. Then all these things would be irrelevant. Now, by this comment, these people were so much disturbed that they actually left. They didn't know how to counter these things. Okay, so he left. And as I said, it was really incredible to stand up to them at that time. There was another thing which happened just about a year later. When I say year later, it is 1975. 1975 already, Indira Gandhi had started his what is called his 20-point program, which would later graduate into the emergency. Well, emergency was declared sometime in 1975. What I'm saying was a little before that. Okay? At that time, emergency has not been declared, but the 20 points program has been declared. Okay? And with 20 points, there were 4 extra points, like you have to pay cess on income tax. Okay? So there were also 4 points, which I don't remember what they are. Now, when new students are coming into Presidency College, the new student union, who are Indira Gandhi's party members, they pass out a questionnaire to the new students. That's not unusual. They would ask what kind of extracurricular activities are you interested in, etc., which the students' union should do. Okay? But then there was one question: what do you think about Prime Minister's 20-point program? And there was one guy who replied, it's a fraud. And of course, it didn't go very well with the student union people. So they got very agitated and again tried to, this was their only solution. They tried to beat up this guy. And this I don't know exactly how AKR came into this picture. But he did. And again there was an exchange between these people and AKR. So they said that, you know what he wrote about 20-point program? He wrote it's a fraud. Then AKR said, well, that's a compact and to-the-point answer. I mean, I have to repeat it in Bengali. ছোটর মধ্যে গুছিয়ে ভালোই তো লিখেছে. So again, they sort of lost all their words and they left. So, as I said, in critical situations like this, AKR was always available to the students. And I remember him very fondly and with great admiration, not only for his role in the class, but for his role outside the class as well. Now, at the end of the talk, I should say something, because the title of my talk said AKR and the teaching of physics. I have already taught about AKR's way of teaching of physics, but I have to make a few comments about what we did not get from AKR or his contemporaries, that is my other teachers, and what I would have liked to get. This is one of the things is that AKR was doing these great research things. We did not know about it when we were a student in Presidency College. I think we should have known. We would not have understood, probably. But we would have understood that he is doing something physics, something research. And probably even we would have understood that he is doing something great, or he has done something great. That much we could have understood or appreciated. We never did. So I'm not saying that AKR would come with a placard saying that I do research. No, that is not expected. But sometimes there could have been some seminars about research work, or some conferences might have been arranged in Presidency College. Nothing like that happened. I'm very glad to say, and by the way, this is also true when we came to Calcutta University for our masters. We have never seen any research work being done, or any research seminar, or any research conference. I'm very happy to say that now the Calcutta University has changed a lot. Almost everybody in the department has an active research program, and the students know about it. How do they know? Because now Calcutta University has instituted a program which will be a term paper, you can call it, or a project for the final year MSc students. So the students would come to us and would ask for project themes to work on, and that way. And there would be seminars. Sometimes they would also organize conferences. Because of lack of funds, it cannot happen very often, but it happens. Okay? And so these are the things which have changed from AKR's time for the better. Something which hasn't changed is that we still haven't been able to guide the students. When I say students, I mean BSc and MSc students, and students who are motivated about physics. There are people who come to physics just to get a degree and for doing something else. Fine. I mean, for them, nothing extra is necessary. But for people who are motivated to do physics, for them, we should have some inspiration kind of things, so that they can find their way into the research world. They can know what they like to do. And this is not done. How can it be done? The answer, some of the answers I have found out myself, and I try to do it on my students. I ask them not to read only the textbooks, but to read also books like The Characters of Physical Law by Richard Feynman, The First 3 Minutes by Steven Weinberg. I say these kind of books will give you a wider appreciation of physics, something that you won't be able to get by reading all textbooks, because that will take you a lifetime. You won't have time to do anything after that. Okay? So to get an idea about many subjects, read Scientific American, for example. Go see the papers in American Journal of Physics. Okay? And these are actually aimed at an audience like you. And you should see this. If you don't read all the papers, I'm not expecting that you will read all the papers, but read all the titles at least, and maybe all the abstracts. You will know what is happening in the world of science. And this kind of thing, we never got it from our teachers. So when I had to do my PhD, I had absolutely no idea of what is to be done. I'm very fortunate that I had this friend, Shumit, who I already described. Shumit got some forms from the American Center, gave half of them to me and says, fill this up. I said, what are these? He said, these PhD applications. I said, okay, but where do I send it to? He said, I will give you the addresses. He gave me the addresses. I sent it to those addresses. Some of those people got back to me saying that you have sent this application, but you forgot to sign. And I said, I'm very sorry that I forgot to sign. I sent the letter, but I forgot to sign it again. So they said, okay, we give up. We cannot cope up with you. Anyway, the point is, we should give them more guidance about life. And by life, I mean a physicist's life. And something also that might help in this way, in this path. That is knowing a little bit about the history of science. Because the textbook gives you the completed formula or the completed theory. It doesn't tell you how people obtained that theory. And that is important. That is important to appreciate what goes on into the research of physics. You all have learned that Newton got this law of the gravitational force. Did you ever ask yourself, how did he find that the force goes like 1 over r square and not like 1 over r to the power 4 or 1 over or e to the power minus r over something? How did he get it? How did he get 1 over r square? And did you ask yourself, what kind of psychological arrogance does one need to say that when I write the force, and okay, I see that it has to be proportional to the masses, and okay, somehow I got that it is proportional to 1 over r square, I put m1, m2 over r square, and the dimensions don't match. And then what do I do? You should appreciate the arrogance of this person. He said, there is something else there. And he called it capital G, or maybe other people called it capital G, which is nobody's property. It's the property of gravitation itself. These are enormous things in the history of physics. You have to appreciate the brilliance of these things. And the only way you can do it is by reading books which are not your textbook. A textbook will not tell you this. So, there are students in this audience. I'm not giving you the advice that, therefore, do not read the textbooks. You should, especially the books written by me. Okay? But you should also read other books. And this is something that we did not learn from our teachers very much. And I feel that they should have guided us in this. And with that, I end. Thank you very much.
Especially the young students who have come from different colleges, we encourage you to ask questions if you have any to Professor Palash Baran Pal. You can ask either in English or Hindi, or you can also ask in Tamil. We have a...
Sure, you can ask in Tamil.
We have a translator, so he can translate the question for you in English to him. So please feel free to ask questions to Professor Pal if you have any. So if you have any, you can please.
Don't think that the question might be naive or something like that. Whatever comes to your mind, whatever you have in mind, you can ask away.
In fact, I prefer questions which are naive because they're easier to answer rather than hard questions. But please don't force them to ask questions. If they don't have any, that's fine.
Sir, you told about 2 books, and one of is Nature of Physical Laws, written by Feynman. And what was the other book, sir?
The First 3 Minutes by Steven Weinberg. Steven Weinberg.
Oh, okay, sir. Thank you. Sir.
Weinberg.
Okay. So where are those?
I mean, those are just examples. There are many books like that. Okay. This is usually called books on popular science. Popular science means that you can read it without worrying about big formulas and so on. So you can read it even while lying down, okay? And even when you are sleeping, you can read them. So this kind of very light reading, this kind of thing. But they give you an idea of the field, some field, without going through much detail.
Thank you so much for the wonderful talk. So I just wanted to know, I mean, if you remember any instance where Professor AKR gave any advice to students or told something to students about being shy about asking questions in class. You know, so any advice from AKR?
To be frank, I don't remember any explicit things like that. But something has to be said in this context. The point is, let's say when AKR was a student, at that time, the model of a teacher was a fearful person. I mean, people would faint when they see them. I mean, this was the thing, okay? This was the thing. That paradigm has changed over the years. And I can feel that AKR felt it, and he tried to fit the new paradigm gradually. And that is the reason he could make that comment to Sudipta, which Sudipta mentioned yesterday, okay? He would not have made this comment when I was a student, okay? This paradigm has changed. And it has changed through some other beautiful teachers who were much junior to AKR. Sometimes they were not as brilliant teachers as AKR, but they were like our friends. And this friend paradigm is now the current paradigm, okay? So, I mean, even if you are not a friend, I mean, you can imagine that with my age, calling myself a friend of the MSc students, the MSc students would say, well, the age is stands something against it. But at least I will have to, you know, appear like a loving grandfather to them, right? So unless you have this kind of rapport with the students will not ask questions. Okay? They'll be afraid to ask questions. And this was the situation. I mean, my father's generation never asked questions. Okay? But now they do. They do much more. In fact, they do more than asking questions. I have some students coming and telling me, you should not have done this. Okay, I have done something and said, you should not have done this, sir. And then I thought about it and I said, okay, you are right. Or sometimes I said, no, I do not agree. I think I should have done this. Okay? So there is this kind of a communication that is getting more and more. And with your generation of teachers, I'm sure it will be much more appreciated and used among the students.
Hi, thanks for the very nice talk. You mentioned something about the level of clarity that AKR had regarding the subject. So just wanted to confirm, like, is it only through experience that such clarity comes, or are there other ways through which you can develop such a clarity of the subject? No matter, it's not just physics, any other subject as well.
Experience certainly helps. But the groundwork has to be done even before you get a lot of experience, right? I mean, I can feel that now I can teach quantum mechanics much better than what I did 10 years ago because of the 10 years of students who have, you know, whom I have seen, okay? But I have learned quantum mechanics before that, okay? So some groundwork has to be done when it should be done, and then, of course, experience is a great help. That's right.
Sir, in your lecture you told...
Where is it coming from? Yeah. Sorry.
In your lecture you told that schools and colleges, they are tied up to a certain syllabus. So what is the best way to approach physics as a beginners, as a BSc graduates?
Okay. Yeah. Maybe I should have said one thing also in that context, that the universities are not so much tied. Because the universities make their own syllabus and teach them. For example, when I teach, say, quantum mechanics to the MSc students now at Calcutta University, that is the course. That is the definition of the course. No matter what is written in the university, brochures, whatever I teach is the course. Okay, so university is freer from this. But your question is really about the lower levels. See, you have to admire the given syllabus. I mean, no matter what it is. I mean, you cannot say, I'm very good, but I always fail in the exams. That doesn't help. Okay? So you have to sort of go with the thing. But at the same time, it might also be good to think what you are not finding completely satisfactory and make a note of them, because you might need them in your future. Like what you said, with experience. This also, as a student also you have some experience, right? So you can start thinking or making a note of things that you really did not like, okay? And that will help you in the future. But you have to abide by the syllabus also. That is important.
Thank you, sir, for the nice talk. Sir, you mentioned that we should try to read the title and abstracts of papers as a practice. So I was if we are interested in a topic, we are searching for the paper, we find a paper, we find something interesting in that paper, and we go to the references and another paper. So, and before we know, there is an endless loop of finding other papers, and there's a series of open tabs in Google Chrome. And so, would you suggest any solution for that? What should we do if we get in an endless loop?
First of all, when I said this, I did not really say that you go to find one particular topic. I said that go to American Journal of Physics and see what they have, okay, or go to Scientific American and see what they have, okay. So by that way, you will be exposed to many more topics. Don't read all of them, okay. Nobody can read everything in a journal, okay. But at least you will see the things. I mean, it's like, voting in an election. You won't vote to everybody, but you should also see all the candidates, okay? So you should see the candidates, and then from that you will get an idea of what is attracting you most, okay? But then, to answer to your question about this endless number of tabs being open, you have to stop somewhere, okay? And personally, I mean, maybe this is not a nice thing to say, but I tell you what I do, okay?
Yes.
I almost don't read any of them and leave it to the referee. So I just write the paper, send it to the journal, and then the referee said, "Come on, you fool! You didn't cite this paper and that paper." I said, "Okay, I'm citing it," and I cite it. Okay, and sometimes the referee said that, "Oh, you have done this, but it was done 20 years ago by such and such." I said, "Okay, fine. Then I'm withdrawing the paper." Okay, so this is, I don't think this is a very good way of doing things, but you will find your way of knowing when to stop. But certainly you cannot go to an infinite loop.
So, what was the reason that you did not go through AKR's paper? Was it really hard? You said in the start of the lecture,
That's a very good question. Well, the thing is, I knew, maybe not at the time when I was a student, but at least after that I knew that his work was on gravity. And gravity means it's a sort of classical gravity, Einstein's theory of gravity, something like that. And my research never took me to that. I did research on particle physics, which doesn't need any gravity. In fact, for doing particle physics, you have to completely neglect gravity. Okay, so I completely neglected it. Okay. I mean, I know gravity to the extent that I can teach an MSc class, okay, but nothing beyond that. I am not an expert in gravity, and AKR's thing is sort of beyond the first course. That is the reason. I am not saying it is hard, or I don't have any way of saying. Maybe other people will know whether it was a hard thing.
Yeah, I have a quick question, sir. You mentioned that AKR used to come to the class without any props. Now, what is your take, I mean, for the teachers for this generation, that should we prepare when we go to the class without the notes, or because I have seen teachers who are excellent in both ways, with papers and without papers while teaching?
You see, it also depends on what you are teaching. And for things that AKR was teaching, I still think it's best to come completely without any props like AKR did. But then there are some other things when one might need some props, and I don't see anything wrong in using them. For example, if you are teaching, let's say how the Higgs boson was discovered, and you want to see the experimental, you want to show the experimental data, okay? You can just come with the experimental data and just project it and show them. I mean, if you draw the experimental data, it will mean nothing, right? So in these kind of things, it's fine. But what I do not like is that if you have to go through, 10 steps of algebra to reach a point, and you write all of them in your transparency or computer, and then project it, that is not good. Because the argument that people give is that, oh, it takes too much time to write them on the blackboard. Yes, it does. But it also takes time for people to observe the thing. And you have to remember, this is called the Garrosh's law. In Chicago, there was this famous physicist called Robert Garrosh. Garrosh said this, and I also learned it from Shumit. Somehow his name comes in many ways in today's talk. So he said that the efficiency of a talk or a class is not measured by the amount of information emitted, but by the amount of information absorbed. Okay? So you have to remember this, right? You need time for writing it, fine, but people will also need the time to absorb it. So for those things, I do not like using any prop.